Chirality as a phenomenon or a concept is very important, not only in chemistry, but also in biology. We have learned before that the two causes of chirality are an absence, if you like, of a plane of symmetry and presence of stereocenters. So let's write that down. So absence of a plane of symmetry is one cause of chirality actually, and we now appreciate that the human hand, for example, is chiral because there is no plane of symmetry. There is no vertical line, if you like, or a horizontal line that cuts the human hand into two halves, if you like, which are mirror images with each other. So therefore, the human hand is chiral, so because it does not have a plane of symmetry. Of course, the other hand is also chiral because it doesn't have a plane of symmetry. But we also know, of course, that the human hands are a pair of enantiomers, which, if you like, which are non-superimposable mirror images with each other. So this is one cause of chirality, is the absence of a plane of symmetry. The other cause of chirality is presence of stereocenters. And of course, stereocenters or chiral centers or asymmetric centers, if you like, or stereogenic centers are carbons, if you like, or centers which are surrounded by four different groups. And we took models in previous lectures, a model like this, for example, where carbon is bonded to four different groups, shown here or illustrated by four different colors. For example, if you take something like that, 2-bromo-butane, obviously this carbon is chiral because it is surrounded by four different groups. So this carbon, therefore, is chiral. That one here, that's again because it is surrounded by four different groups. If you take other examples, such as propane, and if you look at any of these carbons, I'm sure you will find out that none of them is actually a stereocenter or a chiral center. Therefore, propane itself is achiral or not chiral, because there are no stereocenters, no chiral centers, if you like, okay? So stereocenters, again, if we can write them down, these other descriptions: chiral, asymmetric, stereogenic. All of them mean exactly the same, and that is, of course, a center or a carbon that is surrounded by four different groups. So therefore, this compound is chiral because that is a stereocenter or a chiral center, because this carbon is surrounded by four different groups: a bromo group, ethyl, methyl, and a hydrogen. None of these carbons in propane is actually chiral, and therefore the molecule as a whole is achiral. That's because none of them is surrounded by four different groups. If you take something like this, 2-bromo-propane, this is also not chiral. It's an achiral molecule. Of course, at the first glance, you look at carbon number 2, you will see that it is surrounded by two methyl groups. So they are identical, actually. Of course, the presence of two identical groups is sufficient for a specific carbon to be achiral. So therefore, this compound is achiral because it does not have any chiral center or any stereo center. If you take something like this, now, of course, this carbon is not chiral because it's not surrounded by four different groups. This carbon, that one here, the carbon on the right side, is not chiral either because it's not surrounded by four different groups. It's only surrounded by three hydrogens and, of course, this alkyl group. This methyl group is also not chiral because, again, it's surrounded by three hydrogens and the alkyl group. This carbon here is not chiral because it's surrounded by two identical groups, which are methyl groups. But this carbon here is actually chiral because it's surrounded by an isopropyl group a methyl group, a hydrogen, and a bromo group. So therefore, this is a stereo center. So that's a stereo center, and therefore this compound is chiral. So that's another example of a chiral molecule which has a chiral center, a center or a carbon that is surrounded by 4 different groups. Of course, examples are numerous. We can go on and on and on by taking other examples to illustrate this cause of chirality, which is presence of stereocenters. But of course, it's not just the presence of stereocenters, it's also absence of a plane of symmetry, exemplified by the human hand, for example. You will see examples later on which have stereocenters, but they are still not chiral. And of course, I'm sure you will probably predict that it is because of the presence of the plane of symmetry. We will take examples like that in due course.